this video, I'm going to be talking about the basics of intermolecular forces. There's three kinds of intermolecular forces, and the first one is dispersion. It's actually the weakest of all three kinds, and it is always present. So that's the unique thing about dispersion, is that it is always going to be happening between molecules if they get close to each other, because molecules have a natural tendency to react, or interact with each other rather, no matter if they're polar or nonpolar. The type of interaction that does rely on polarity, though, is dipole-dipole. It only occurs between polar molecules. And a prime example of dipole-dipole interactions is in water molecules. So right here we have two water molecules. There's a negative and a positive end, and then a negative and a positive end. Now, as you can see right here, the positive end of this one and the negative end of this one are interacting with each other because of the principle that opposites attract. Now, that is contributing to why water has such a high boiling point, but the main reason for water's high boiling point is hydrogen bonding. Now, hydrogen bonding occurs between hydrogen and nitrogen, oxygen, or fluorine. Now, in water, it's hydrogen and oxygen that are interacting with each other. And the thing about hydrogen bonding is that it's very, very weak, even though it's the strongest of these three intermolecular forces. When compared to covalent or ionic bonding, all three of these are extremely, extremely weak. But the thing about these is that if you have a long chain of these types of forces, it actually becomes somewhat strong. It's like having a piece of Velcro. So if you have a small piece of Velcro, it's really not that strong. But if you have a long strip of it, it's a lot harder to pull apart. So that's what makes hydrogen bonding so important, especially in specific heats. So for water, water has a very high specific heat, and that is largely contributed to the fact that there are so many hydrogen bonds within water, like between the molecules. So hydrogen bonds hold these water molecules, as well as like dipole-dipole interactions, but the hydrogen bonds hold these molecules so closely together when boiling water, so breaking those bonds is a lot harder because there's so many of them. And the key point to take away from hydrogen bonding is that not only is it strong in numbers, but it is not a bond. Hydrogen bonds are not bonds. They are simply really strong interactions between molecules. None of these are bonds, but hydrogen bonding is strong, but not compared to other types of bonds. Now, as a recap, we've got dispersion, which is otherwise known as van der Waals or London dispersion forces. We've got dipole-dipole between polar molecules, and we've got hydrogen bonding, not a bond. Hydrogen bonding, the strongest of the three. So, thank you for watching.